My name is Carlo Pelt. I am from Amsterdam University of Applied Sciences and I'm a graduate student here at Holland Composites. I've been assessing the quality of cosmetic fillers for the application in wind turbine repairs. If a wind turbine is damaged on the surface, then you could basically fill it up with a kind of putty-like substance which will harden, and you could sand it off, which will only function like a sort of temporary repair. It doesn't really restore the mechanical properties of the blade itself, but it does prevent the damage from propagating further. An intern before me in the last year has already designed and produced an automated injection robot, which would be able to apply any filler to the damaged area. But it hasn't been perfected for the most suitable filler, which was my job to find. So I started with a literature study in which I looked into the load cases that a wind turbine is generally being subjected to. I also looked into the environment, which also plays a big role, like how UV radiation has an effect on the quality of the blade or the quality of the repair. I also looked into different kind of fillers, like how do they actually work, what makes one filler better than the other one. So after the theoretical research, I selected 3 fillers that were the most eligible options. I've used those fillers to repair composite samples. Those samples were then to be subjected to environmental weathering conditions, the UV radiation, water submersion and thermal cycling. After that, I've tested them on tensile adhesion, shear adhesion and hardness of the filler itself. After those tests, I have established and verified that the filler that I had the highest expectations for actually was the best performing filler after all. It was a filler that was already being used for cosmetic wind turbine repairs, but it didn't always perform best in all the tests. Like only in one of the 3 tests it performed best, but considering that it almost exceeded the performance of the other fillers, I think it will be the most suitable filler after all. It can be concluded that the Force filler was obviously the best one, not only because of its adhesive performance and its hardness specifications. It was also the most simple to use. Its viscosity allows it to be used on not only horizontal surfaces but also upside down surfaces and vertical surfaces. I would recommend my successor to assess the fatigue processing of adhesion. Like I did the tests only once, which means that I did one destructive test, just apply a force on a sample until it breaks. I did not assess anything that considers fatigue or thermal fatiguing for that matter. So I think that will be a great start.